Welcome to VW 7.6. Today we're going to talk about how to graph these by hand. So first, let's write this down. F of x equals a sine bx. And that a right there, hopefully you realize from the worksheet that that corresponds to the amplitude. So to formalize it, we're going to write the absolute value of a is actually the amplitude. And for the b, hopefully you realize from that worksheet that it relates to the period. And the relationship is this. The absolute value of 2 pi over b is equal to the period. So make sure you box that. That should be in a nice place in your notes. And we're going to start by graphing this basic sine graph. So I just copy and pasted this t I have. I recommend you do that too. It just makes it faster when you're working. You're going to put 0 right there in the middle. That's your x-axis, and I'll put x right there. You don't have to. It'll be implied. I'll put y up there. The amplitude here is 1. So you're going to write that. A equals 1. Now the period, notice how there's a 1 in front of that x. So we're going to write 2 pi over 1, which is 2 pi. Now we're going to use that to scale everything. So the amplitude means you're going to go up 1, down 1. Now for the x-axis, the way this works is you're going to put 4 tick marks evenly spaced. 1, 2, 3, 4. The fourth one is a little bit bigger because you're going to make that this period value. That's 2 pi. Now what you do is, using this fourth one, go to the second one next, because that has to be half of 2 pi, which is pi. Now go to the first tick mark, because that's half of what you just did. Now that's pi over 2. And now the third tick mark, think of this one, this times it by 3, and you get 3 pi over 2. Now we graph it. Sine starts in the middle, so put your dot right there. And notice how it's just going to go up because it's positive. So there's the first point, next point, next point, next point. And sine graphs and cosine graphs are really nice to graph because they're very predictable. They're always going to be evenly spaced, and they're going to increase and decrease in the very same way. It's very pattern oriented. So now here's your graph. I'm going to label my points. So that's 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. This is one period, and of course, because this goes on forever, so if you wanted to, you could illustrate that this continues indefinitely. But for our class, we're just going to graph one period. Now it says domain and range. So domain is actually all real numbers because of what we just said. This graph continues indefinitely, so this goes on forever. Now the range is going to be from negative 1 to 1. And we can see that the lowest point is here, the highest point is here, and the graph constantly oscillates between these two forever. So there's our first graph. Now let's go to cosine. So the pattern you're going to follow is you want to identify your amplitude and period. So A is once again 1, period is once again 2 pi. Then you're going to want to have your t. So here's my t. Now label 0, 1, negative 1, 1, 2, 3, 4. Your fourth tick mark is your period, 2 pi. And now I just scale appropriately. Pi, pi over 2, 3 pi over 2. Now the difference for cosine is cosine typically starts at this top value, this 1. So now I just continue the pattern. And there's our first wave. Try to make it as smooth as possible. You don't want any jagged edges here. Now I'll label 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and 2 pi 1. Our domain is once again everything, and the range, same as last time, -1 to 1. It's not too bad. So for our next two examples, they're going to be a little bit more difficult. So let's try it. A is equal to 3. The period is 2 pi over b. It's 2 pi over 2. So that would be pi. Now we're going to put our t in right there. Label 0. We're going to go up 3 and down 3 this time. Go 1, 2, 3, 4. The fourth tick mark is pi. Now scale appropriately. And now we're going to graph. So sine starts in the middle. So start your point in the middle right there. Notice how it's positive 3. So it's going to start by going up. And now just follow the pattern. Let's label 0, 0. Pi over 4, 3. Pi over 2, 0. 3 pi over 4, -3. And pi 0. Our domain is everything. So you'll notice that the domain for all of these will be everything. And the range is simply -3 to 3. Last example. A. P at this point you should feel pretty comfortable. 2. Let's go straight to 4 pi, because if you're dividing a fraction, you multiply by the reciprocal. Let's put our key right there. So 0, 2, -2, 1, 2, 3, 4. Fourth tick mark is 4 pi, which is nice because that means every tick mark is simply pi. Now this one's going to be a little different. Normally cosine would start up here, but notice how it's negative, which means it's going to flip it. So the first point is actually right there on the bottom. And now we just continue the pattern of the wave. And there we have it. There's our cosine wave. Let's label 0, -2, pi 0, 2 pi 2, 3 pi 0, 4 pi -2, and there it is. We can put domain and range right below. Domain is everything, and the range is -2 to 2. Now let's do a couple summary tips here. For sine on the left, notice how all the signs are starting in the middle. So I'm going to put a big star here. Star. Sine starts in the middle. And that's true no matter if it's positive or negative. And that happens because sine of 0 is 0. So no matter what, because of this factor right here, you're going to start at the origin. Now cosine's a little bit different. Notice how on our first example, cosine started at the top, but on our other example, cosine started at the bottom. So for this one, we're going to put a big star here. We're going to write cosine starts at the max or min, and that depends if it's positive or negative. Okay, so working through the problems, and once you're done, go on to the next part of the video. So now that you've graphed those problems, we're going to graph the more advanced ones now. So notice how this one has this piece at the end, that -2. So that's going to mean the graph is going to shift down 2. I'm going to show you a method called the midline method that's going to make this a lot easier. So first, we're going to write the generic form here. This is what we're working with today. A sine bx plus k. We now know that the absolute value of A is the amplitude. The absolute value of 2 pi over b is the period. And some people call k the vertical shift. For our class, I want you to think of it as the midline. It's going to be helpful in thinking about it in a new way to do these problems. So for this question, let's start by doing the usual t, like that. But notice how we have a midline here. This is our -2. So what I'm going to do is do a partial erase and erase the middle to make a dotted line like that. And I still recommend doing your basic information. We can see your amplitude is 4, the period 2 pi over b, so that would be 2. And we can see our midline is -2. This midline right here, that's the value we're going to put at the middle. Our a is 4, which meant if you go up 4 here, this is 2. Down 4 is -6, which means our x-axis is right there in the middle. So let's put that down. Now we can scale it. So 1, 2, 3, 4 tick marks. And I recommend scaling the midline because it's a little bit easier to look at. We can see the fourth tick mark is 2, the second is 1, the first is 1/2, so the third must be 3 over 2. And now let's put our points down. This is a -4 cosine wave, so we'll start at the bottom and follow our typical wave pattern of middle or bottom, middle, top, middle, bottom. Let's put our wave together. There's one period. Let's label this 0, -6, 1/2, -2, 1, 2, 3 over 2, -2, 2, -6. On our domain and range, our domain is definitely all real numbers like usual, and our range is going to be inclusive -6 to 2. Here's our last example. Let's put A, P, the amplitude is 1/2. The period is interesting, so write it up. 2 pi over 8. That's 2 pi times 8 over pi, which is 16, so pretty interesting. And the midline is 3 over 2. So notice how a question like this, if you were to do it the traditional method, to shift the graph up 3 over 2 units would be pretty difficult. But with our method right here, this is going to be no problem. I'm going to partial erase to get my dotted line. The middle is 3 over 2. And if the amplitude is 1/2, if I go up 1/2, that's going to be 2. If I go down 1/2, that's going to be 1. Now I'm going to do a shortcut. If you do a squiggle like that, that means approximate. So that way it's not to scale. The 0 is right down there, so I just approximate to 0. And now we have a nice scaling. Let's mark it. 1, 2, 3, 4. The fourth tick mark is 16, so that's 8, 4, and 12. Now all we got to do is graph the sine wave. We know sine starts in the middle. And notice how this is negative. So that's important. That means we're going to go down first. And now I just follow the pattern. Let's label 0, 3 over 2, 4, 1, 8, 3 over 2, 12, 2, 16, 3 over 2. Our domain is once again everything. And the range is going to be 1 to 2. All right, so that's it. Good luck on the rest of the problems, and I'll see you in class.